G'day there. Today we're going to talk about position lines. Now, position lines are lines on a map or on a chart which represent all of the possible positions that you could be. In other words, they don't indicate exactly where you are, but they indicate the positions that you could be. I'll explain. A bearing is a position line. So if this lighthouse is on a bearing of 280 degrees, that means that you are sitting on the 280 degree position line. So you can be anywhere on this line that represents 280 degrees. So you could be here and have a bearing of 280 degrees, you could be here and have a bearing of 280, or you could be out here and have 280. So you don't know exactly where you are, but you know that you're somewhere on this line. Another type of position line is called a transit. Now, the transit is where two known objects line up, and you can see those objects lined up. So if you're out on the sea here and you can see this lighthouse is aligned with this hill, then your position is somewhere on this line. Again, you don't know exactly where you are on the line, but you know you are on the line. So you can draw that as a position line on your chart. Similarly, if you are following the lead lights into a harbour, or you have two known lights that are on your chart and you have them aligned, you can see one behind or above the other, then you know that you are on that transit line. So that is another position line that you can put. Again, you don't know exactly where you are on the line, but you know you are on the line. And so that helps us determine your exact location. Another form of position line is the line that is produced as you cross between one sector light and another. A sector light is a light which indicates by its colour areas of danger and areas of safe water. In this case, the red light represents areas of danger and the green light represents areas of safe water. Where you travel from one colour to another, you will cross a line where the colour changes. Now, that line can be used as a position line. In other words, if you are on the position where it changes from one colour to another, you know that you are exactly on that position line. You don't know where you are on the line, but you know you are on that line. So you can draw that on your chart as a position line. Not all position lines, however, are straight. Some position lines, like this one, are curved. Now, this position line is developed from what is called a horizontal sextant angle. I'll link down below a more detailed explanation of how horizontal sextant angles work, but simply understand that a horizontal sextant angle is a measure of the angle between two objects. So if you're sitting out on the ocean, you have a sextant, which is a device that measures the angle between things. And so on your sextant, you're reading that the angle between this lighthouse and this lighthouse is 32 degrees. With position lines, or with the horizontal sextant angle more specifically, measuring 32 degrees doesn't tell you exactly where you are, but it will tell you that you lie on an arc. And this arc has many positions where that angle is 32 degrees. So you can use it like any other position line. You can say you know you're on the line somewhere, but you don't know exactly where you are. Another curved position line is created from the vertical sextant angle. Again, the sextant is used for measuring angles of things. And in this case, we're measuring the angle of the height of this lighthouse. So we're measuring the angle to the shore. In this case, we get 28 degrees. Once again, I'll put this in more detail in another video, and I'll link that down below. But understand that with the horizontal sextant angle, we can determine from the height and the angle, we can determine the distance that you are from that lighthouse. Knowing the distance from that lighthouse, you can draw an arc of all of the places that have that same distance. And you can say that you are somewhere on that arc. Again, you don't know exactly where you are, but you know that you're on that position line somewhere. So to take a fix is the next step that you need to do. And a fix is simply a combination of multiple position lines. So I'll say that again, a fix is a combination of multiple position lines. So let's say you have two position lines. One here, you see a lighthouse that's bearing 315 degrees, and another lighthouse that is bearing 270 degrees. Well, you can draw those on your chart and you can get an intersection. Now that intersection is known as a fix, and it is a fairly accurate representation of your position. It's called a two-bearing fix. If you want to get more accurate, however, you would take 3 bearings. You would take a third bearing to ensure that the first 2 are correct and have you in the right area. If you make a mistake, then you could have this one out here and you could think that you were much closer than you were, or could have you out here, have you much further. So we take a third bearing, and that gives us what's called a 3-bearing fix. Now you can see in this case the third bearing is a bearing of 240 degrees down to this lighthouse here. And you can also see that the 3 bearings don't exactly intersect. So this one comes over the top here, and this one's over the top and down here. And so it creates this area that's, it's got several names. It's known as a cocked hat. It's known as a triangle of uncertainty. But what it tells you is that these 3 bearings are not exactly right. And so you know that you are somewhere within this triangle, but the 3 bearings are not giving you a precise fix on your location. So it's just something you need to be aware of, and it's a really good reason for taking 3 bearings rather than 2. It provides that double check that you are actually accurate in your bearing taking. Now I should point out at this time that the bearings that I've drawn on here are true bearings. If you take a bearing on your compass, you need to convert it from magnetic to true before you draw it on your map. And again, I've done a video on this. I'll link it down below. You can have a little look at that. But it's really important that you don't just take a bearing from your compass and draw it in on your map with your protractor, because you potentially will have the wrong bearing drawn on your chart. So that's a little trap for young players. But have a look at the link below, and hopefully that will help you with true and magnetic bearings. So the last thing I'm going to talk about is, when you're taking bearings of items on the coast, is trying to get ideal bearings. Now, an ideal bearing is bearings where the various objects you're taking bearings of are about 60 degrees apart. 60 degrees apart gives you a nice difference between the items that you're taking bearings on, objects that you're taking bearings on. It allows the lines to cross at a reasonably wide angle, and it makes for more accurate bearing taking. If you take a very narrow bearing of 2 objects, you'll see that where they cross is a lot longer. Because of the thickness of the lines, it's hard to determine here exactly where the 2 cross, as opposed to the 60 degree where the crossing area is a lot shorter. I might even just zoom in on that a little bit and just show that to you again. So you can see that the crossing area here is quite short in comparison to the crossing here, which is a lot further. So that's all I have for you on position lines and bearings and fixes. I hope that information was of help to you. If you like this video, then please give it the thumbs up down below. I'd really appreciate that. Also, if you have any comments or ideas or suggestions, then please let me know in the comments below. I'm always learning this stuff, and I'm really keen to hear any ideas you have for any other videos. So be sure to leave us a comment below, subscribe, or give us a thumbs up. Okay guys, we will catch you soon. Thanks for watching. Bye-bye.